Hello, everyone. My name is Broderick Bellard, and I'm here to present my capstone under the advisee of Dr. Shamit Saha and Dr. Abdullah Ahmed. So let's go ahead and get started with. So here's the presentation overview, just a brief introduction, motivation, and background, followed by the technical design of HeartWise, as well as the workflow and the governance loop with the study design, key findings, limitations, and future work with and the impact. So just a little background. Heart failure is basically your heart not being able to fully pump blood adequately around your body, and it's extremely common due to lifestyle choices as well as injuries to the heart. About 1 in 5 adults over 40 will develop heart failure, and the mortality is extremely high at 80%, which is why in 1 in 8 deaths can be attributed to heart failure. So it's a very huge problem that's only growing. And another reason for this high mortality rate is due to the symptoms progression, because there's these things called decompression episodes where basically your heart function rapidly deteriorates. And if this happens enough times, it could lead to mortality or death, because every time you have an episode, your muscles get weaker and weaker. So there's only so long your heart can sustain that before, unfortunately, you have to, you pass away. But because of this pressing concern, there are a bunch of different solutions out there currently through the Center of Digital Therapeutics in Toronto, Canada. They developed an app called Medley. So basically, you're able to communicate with your caregiving team Monday through Friday on weekdays. So if you just have a random question like, hey, is this too much salt in my dinner or something like that, you can shoot a quick message to your healthcare team. However, what happens when the nurses and doctors go home and you have a question at 1 in the morning? So there's a need for an asynchronous method to get the heart health information that you need. So that is why HeartWise was created. We also partnered with the Center for Digital Transformations, and we identified that gap of patients need support outside of clinical hours. So HeartWise is there as a 24-hour guide for self-management that's grounded in actual clinical information, and also that the answers are just not whatever the LLM says, that these answers are vetted through a rigorous interview process. So before we even can begin answering questions, we need to establish a knowledge base. And that was a project within a project, I will say, because I had to scrape the Heart Hub website. That is a website in connection with the University of Toronto and Medley. So that website is part of their hospital, so it has been, verified by clinicians. So it's a safe place to start. So I scraped and I processed with different information, like the website at the top, different markers for injection can be easy. And then that led to semantic chunking. And also we had to cut up the documents so they can be easily understood by the LLM for the RAG database, as well as embed it and also store it. And we used anything LLM for the RAG integration. So RAG just stands for Retrieval Augmented Generation, and it's a great way to add to the capabilities of an LLM. And using anything LLM, we were able to store everything that we needed. Next came the prompt engineering because, again, there's so much that goes into talking about your heart and heart failure. So we had to essentially instruct the LLM about how to act in certain situations, like telling it it's an experienced cardiologist, as well as you only talk at a 6th grade level, and things about self-harm and intent were also added. We also, like I was talking earlier about building a mechanism to check the outputs before they reach the end user. We had that using an LLM as a judge, which basically goes by and we give it a criteria and it goes and grades the information. So, and then across 5 dimensions, we score 1 to 3 just because we wanted it to make it easy. And the literature suggests there's no real difference between like a 4 or a 5 or a scale of 1 to 5. So, as well as we wanted to make sure that there was a governance loop, like I said, to help curb hallucinations and just misinformation getting to the end user. And of course, with any data science project, especially one in clinical informatics, we wanted to take a short consideration for the ethics, mainly centered around appropriate use as well as transparency and trust, because we just don't want to let out a rogue AI to say whatever about heart health on our watch. So it was very important for us to understand the implications of what we are making. So after all that background, we finally get to the actual HeartWise system. It's basically 5 distinct parts where we have a router agent that kind of talks, that queries on intent. What type of question is this? Is this a can I exercise questions, or what happens if I skip the dose? And then, like I was said earlier, we use anything LLM as the vector database just to store the RAG documents for retrieval. And then we created the answer generator, which is ChatGPT API call. So that serves as the brain of the situation. We also did a LLM as a judge again to check the information that is coming out of the answers and to see and to help with hallucinations and all types of misinformation. We actually have an iterative governance loop, whereas based on the scores for the initial answer, the judge will give hints for the answer generation to rewrite so it can have a chance to do a do-over just in case an answer isn't as strong as we want it to be. So this takes us to the workflow. So like I was explaining earlier, so a user will input a question like, what happens if I eat this food for dinner? So that will then, so that question will be sent to first draft, where HeartWise will use its knowledge base to answer said question and then have a response, followed by a LLM as a judge evaluates for 1 time. The draft is scored 1 through 3 across the 5 dimensions, and there's different edits and suggestions that are provided. So once all the decisions, if the scores are all 3, then the user, the output would be released. If not, it goes for that rewrite, which again, after that rewrite, the judge will evaluate. And we made a decision for about accuracy and safety. If those were 3, it will be released. If accuracy and safety were not at a 3, then a safe fallback will be triggered. So now that we built the system, we have to test the system. So we made a synthetic heart failure data set, just 30 simple questions that we think would come up in everyday conversation, followed, and then we tested out the system with a main focus on how reliable is the judge, meaning we created an answer question pair, and then we ran the judge at different temperatures 3 times each. So that gives us a solid baseline of, okay, so how is this behaving? Then we took the same judge and put that into the behavioral loop, meaning the governance. So we did the exact same thing, only if it wanted to do a retry, it got a retry. And we did 3 separate inferences again, just so we can see, okay, so how reliable is it in isolation? How reliable is it in the full governance loop? And there we ran different analyses for score stability, as well as inter-run ICC3 and ANOVA. And we also wanted to do rationales because the judge does give out a, hey, why did I gave a 3 in accuracy because of this reason, as well as overall governance matrices. So I've been talking about 5 dimensions for a while, so let me go ahead and define which the metrics are. So the accuracy, safety, robustness, empathy, and clarity. Again, we consulted the literature, and this is what we saw for what would be the most interesting ways to measure the judge evaluations. So with that being said, here's an example of HeartWise at work. So we give it a question like, how's this, can I work a full-time job, right? So it gives us an answer that it is scored, and then we see robustness is 2. So give it a retry for an explanation if symptoms worsen. So as you can see for what's in highlighted in the red, this is what's now added. And after a rescore, this is safe, full perfect scores across while maintaining all other scores while improving robustness. So as you can see, when we did this for temperature, we saw that the mean judge score was pretty stable. There was only, the lowest score was robustness, and that's because how strict we made the guidelines. And so while we were looking through the scores, we then noticed that while the score, like let's say for example, all 3 runs gave a 3 for accuracy. However, the rationales were different. And that was a point of motivation for the full governance loop study. And as we noticed, that semantic similarity of the judge dropped as temperature increased. So we wanted to then test, then we took a look at the hidden instability of the judge across the different dimensions. So as you can see, clarity had the most hidden instability while safety had the lowest. So that's a good thing. But at the end of the day, we want the system to be reliable. So we now know that it's not the best practice to just rely solely on scores, that you need to understand the rationale behind the decisions made. So when we then took this information and applied it to the full governance loop, that we initial takeaways was that the first attempts virtually never worked, that our judge caught all the bad input or all the bad outputs before they were released to the final user. As you can see as well, final pass rates, meaning after 3 attempts, that within 3 attempts that the final answer will be given to the user and the fallback is not created. So once we saw that, we saw, okay, so the judge is working as intended. And then we broke that down again by temperature as well as how many attempts it was needed. So usually it took between 2 to 3 attempts to get a good quality answer. And this also lets us know that the system is behaving as a genuine multi-round editor. So again, we also saw about a delta 1.28 for average scores improvement across the judge temperatures, with 0.5 being the best for judge improvement. So that means that 0.5 temperature is the best when it comes to the trade-offs between being strict or being as loose with the judgments. And again, just taking a look at the final pass rate for temperature, as you can see, 0.5 is the optimal temperature to use when using a LLM as a judge. So some key takeaways from this capstone was that judge score, just because a score is stable, that doesn't mean the reasoning is stable, as well as the judge loop is a reliable mechanism. It caught about 60 to 70% of bad scores before they reach the end user, as well as you need to be able to audit the system for things like rationale, just to understand what's going on within your systems. And of course, there were some limitations about this study because we just used TF-IDF. So it was a shallow representation of rationales, meaning like, for example, if I were to say I have heart palpitations or my heart is racing, we recognize that it's the same, but sometimes it takes a deeper semantic search to understand that, as well as we only used a single judge and these scenarios were only synthetic. They weren't real. There weren't patient interactions. So as well as it's only one modular backbone, and there was no adaptive or learned behavior in the retries. It was simply based on the written edits. But we hope to address that in the future, like I said, doing a deeper rationale analysis, also breaking the judge up into multiple components based on the dimensions or the metrics, as well as being able to actually have an adaptive governance loop, better reasoning so that we're not just relying only on the governance loop to catch it. We want to be able to have first tries being able to go out of the system, as well as to be validated for fairness, as well as how clinically accurate the system is. So we have some outcomes already for this system. We did a workshop for AMCB, BCB, as well as we got accepted to IEEE Big Data. And today we actually got accepted to IEEE EMBS. So that's very exciting. And all these results and more are being compiled into a manuscript for a JMIR publication, hopefully in the future, as well as being able to do an abstract in the coming months. And as always, I want to acknowledge everybody that helped me through this project. And thank you so much. Even if you're not listed here, everybody in the program has helped me tremendously through these last 2 years. So thank you so much.
So both LLM presentation is very good, huh? So any question, any suggestion for Broderick? Or we can go for a 2 minutes break. We'll be back by 6:45 CST sharp.
Dr. Chatterjee, there is a question on the chat.
1 second, let me read it. I'm curious, what did you train the system on? Can you elaborate on that, Broderick?
So we trained the system mainly on the curated data sets, as well as the personas. That was the main grounding of the system. We didn't necessarily do any like supervision training. It was mostly prompt based, but that could be a future work as well, developing our own local model and training it on heart healthy data.
So just to be clear, Ernest, that's a great question. We didn't fine tune the model. It's more like a prompt engineering and RAG-based system on a already defined GPT-4 model.
And I think they have showed the what is the before and what is the after the prompt engineering, the score, right?
Yes, so we have two systems. One is the chatbot itself and one is the judge. So we have two different, you can say, LLM working, one giving answer, one judging the answer, and refine the answer.
Yes, two projects, both are an LLM. One is just making the LLM on his own, just Isaac did, and what Broderick did to be summarized, so that he just compared and come up with, I think, the comparative score or something like that, and maybe some they can do some more in the future, right, Broderick?
Yes, that's a goal. So I'm going to continue this through my PhD. So I'm going to continue to refine the system.
Yes, welcome on board.